Alright, so 3.1 exponential functions. It's about 11:10 on Tuesday night. I won't be there tomorrow or today whenever you're watching this because my daughter is home sick. So watch this. She'll be back on Thursday, so you should be ready to go. So whenever we deal with exponential functions, basically what we're looking at is a certain base to the x power. So we've dealt with quadratics, we've dealt with polynomials, dealt with rationals, now we're getting into exponential functions. So the big thing is here down at the bottom, like whatever your big number is, that's your base. Base of 2, base of 10, base of 3, base of 1/2. So whenever it's going to be something other than 1, okay, it's normally not going to be negative. If it is, we'll get into that later. So whenever we have any sort of exponential function in a graph, okay, you have different parts. Your domain is always going to be negative infinity to positive infinity. Okay, your horizontal asymptote, that is, if we write this in terms of y equals a times whatever my base of x is, okay, now I'm still going to go x minus h and then plus k, okay, as far as whenever we graph it. So my base is my own base. A is still my scale factor, okay. The k, whatever this is, that is going to be my asymptote, okay. So whatever k is, that's my asymptote. That's where the exponential function is either landing, going to, taking off from, whatever you want to call it. Your range, now some of you that had me last year, your range is basically normally going to go from 0 to positive infinity. I like to say that it goes from k to positive infinity. If it's normal, if it's to a positive base, or if your base is positive, or if your a is positive, it could also in some cases go from, if it's flipped, it could go from negative infinity to your k. Okay. Again, it's not going to land on that value. Okay? It just depends what it does. Normally, 2 to the x power is your that's your parent function. If you look over on the wall, that's going to be the main one on the poster. So we'll kind of go through the easy way of graphing this and some of the things that you have to do, and kind of take it one step at a time. So kind of going back to where we showed examples of when it was an exponential function, here's when it is not. Basically, the ones down here towards the bottom, these are all ones that are not exponential functions. So when x is your base, that's not going to be an exponential function. When your base is 1, okay, it has to be something other than 1. It has to be a positive constant value. Okay, so again, like we said, it has to be positive, so it can't be a negative. Okay, that sends up a red flag. And then it can't be the base and the exponent or the power can't be the same value. Can't be like 2 to the second. Can't be x to the x power. Okay, that just doesn't. That's not how it's going to work. So from here, whenever it says the exponential function f of x equals 42.2 times 1.56 to the x power, okay, it models the amount spent in dollars at a shopping mall after X number of hours. So what's the average amount spent to the nearest dollar? Well, all you're going to do is just basically plug and chug. So we're going to go take that 4, plug it in for our x. So we're going to have 42.2 times 1.56 to the 4th power. Now, what I would suggest when doing any of these is to do my exponent first. So take 1.56 to the 4th power, and then I would multiply it by the 42.2. So you can do it all together, but just it's going to help eliminate. Don't round. So like if I have 1.56 to the 4th power, it's 5.922408896, whatever. Okay, multiply that by 42.2. Okay, so I'm going to have a value, so to the nearest dollar. So if I have 242 or $249 and 92 cents, 93 cents. Okay, now to the nearest dollar, so we're just going to call this $250. Do the same thing. Okay, now it's after 3 hours, so I'm going to take the 42.2 times 1.56 to the 3rd power. So it's no different. I'm going to take 1.56 to the 3rd power, take it, so that's 3.796416, multiply that by 42.2, end up with $160.21. So if we round that to the nearest dollar, I'm really just looking at $160. Now, whenever we get into graphing, one thing you want to look for over on the one wall where the graph paper is look for the one that says exponentials. There's basically 4 main things that we have to find. We have to find the y-intercept, we have to find the asymptote, the domain, and the range. Okay? So remember, the asymptote and the range are going to go together. Okay? So asymptote and range go together. The domain is always going to be negative infinity to positive infinity. Okay? These two go together. So basically, if it's going up, it's going to go from whatever your asymptote is to positive infinity. If it's flipped and it's going down, then it's going to go from excuse me, it's going to go from negative infinity to your asymptote. So those two are always going to be linked to one another. So whatever your asymptote is, whatever it's going to be y equal and then whatever number. Okay, that number is going to go right down here with your range. Okay, no matter what. Okay, I don't care how big, how small, whatever it is, it will go down there with it. Okay, whenever we do our x-intercept, all we are going to do is just take our value, okay, or our y-intercept, excuse me, and we're just going to plug in 0 for x, okay, every single time. Okay, one like this, basically about 6 points. You're going to get 1 for breathing, 1 for doing the graph, and then 1 for each of these here. Okay, so you're always going to find the y-intercept, you're always going to find the asymptote, you're always going to find the domain, you're always going to find the range. So if we have f of x equals 3 to the x power, okay, again, this is one of those that you can always do this without a graphing calculator. You don't have to have one. So if we take it, remember, we have 3 things that we have to find. We have to find the y-intercept, we have to find the asymptote, we have to find the domain, and we have to find the range. So again, first things first, domain always negative infinity to positive infinity. Now again, we are looking for y equals a, whatever our scale factor is, times b to the x minus h power plus k. Okay? If there is no k, right, there is no k back here. So that means that our asymptote is just going to be at y equal to 0. So once you have your asymptote, all I'm going to do is take it, and I'm just going to draw my imaginary line there at 0. Okay, you might be able to see it in red. Here, let's see if I can get it a little bit better. Black. Okay, right there. So then, find the x-intercept. Well, what do we do for the x-intercept? We take the x, we plug in 0. So we go y equals 3 to the 0 power. Anything to the 0 power is 1. So I'm going to go 1. Okay, so that right there tells us what my range is going to be. If it's above that asymptote, okay, if it's above that imaginary line, it's positive. So that means it's going to go from 0 to positive infinity. Okay, then it just becomes graphing everything. Well, a little bit of plug and chug. 3 to the first power is going to be at 3. 3 to the second power is going to be at 9. Okay. And then just run my graph kind of along this line and then take it up. Okay, don't overcomplicate this. You really don't even need a graphing calculator for any of this. Same way over here on 3. All we're going to do, we've got to find 4 things. We've got to find the y-intercept. We have to find the asymptote. We have to find the domain. We have to find the range. So, domain, automatic, negative infinity, positive infinity. Asymptote, again, nothing out here, so just y equal to 0. So, imaginary line, right there at 0. Okay, just dash line all the way across. Same way, find the y-intercept, plug in 0 for x. So, 1/2 to the 0 power, just going to be 1. So, I'm going to have a point right here at 1. Now, you have a base other than, that's not bigger than 1. Okay? So, if it's less than 1, so if your base is basically between 0 and 1, it's a fraction. It's a decimal. Something less than 1, bigger than 0. Okay? Can't be negative. Negative just means it's going to flip. So if it's between 0 and 1, okay, this is what's considered exponential decay. Okay? So with exponential decay, what's going to happen is my graph's going to come in and kind of land like a plane. Okay? If it's coming from the bottom up, it's like a submarine coming from the bottom of the ocean up to the top. Okay? Again, it's one of those things that if you plug in numbers, okay, and you plug in values, if I have 1/2 to the negative 1 power, okay, then it's just going to flip that value and it's going to be at 2. So it's going to be right here. Same way, if I plug in 1/2 to the first power, that's just 1/2. Okay, so it's going to basically be landing, okay, kind of coming in hot, like this here. Now, basically everything, kind of the characteristics of the function is a lot of the things that we've already talked about. This is really just for a standard normal exponential where there's no movement with it. Just that normally your y-intercept is going to be at 1. Okay? Again, it depends on if you have an asymptote other than 0. If there's a k on the back end, that sort of thing. If it's between 0 and 1, then it's going to be exponential decay instead of exponential growth. And growth is going to climb, decay is going to fall to wherever our asymptote is. So, alright, so here again, already showed you kind of our original equation, a b to the x minus h power, and then plus k. So kind of going off what everything has already been written, it's going to be a vertical translation. Basically it's going to move up or down depending on what your sign is with k. Okay, we already talked about it earlier that your asymptote is whatever k is. Now, just like everything else we've done, remember, like the k is going to move everything up or down. Like I said, that's going to be the asymptote. Moving anything left and right is going to be depending on what your h value is and if it's positive or negative. Remember, it's always going to be opposite on the top. So if it's a negative or a minus, it's going to move right. If it's a plus, it's going to move left. So what that means is that's what all we're really moving is our y-intercept. Okay, if you think about it that way, if it's like we're grabbing the graph at our original y-intercept, and that's how we're moving everything. So whenever we reflect, we're going to reflect, if it's negative out in front, we're going to reflect it over the x-axis. If we have a negative up top, it's going to reflect over the y-axis. So basically flip it left and right. So of any of these graphs, there's one I need to fix with the horizontal. The purple, blue, whatever we're calling it, is the original, and then the green is kind of the new graph. So again, we're just flipping everything over from there. So now whenever we have our A value is out in front, so whenever our scale factor, and that's going to deal with the stretch and the shrink vertically. So if it's above 1, okay, if A is bigger than 1, then not talking positive, negative, and above 1, just looking at it, that value, and it being above 1. If it's negative, it'll flip, and then the stretch or the shrink is all dependent on what that value is. So whenever we stretch vertically, similar to like how we have it here, okay, it's going to get pulled up higher, whereas whenever it's a shrink, it's going to get pushed down. So then kind of the second part of the last part, I'm going to have to scroll up, is when we are dealing with horizontal, shrink, and stretch. Now, it's backwards, depending on, I really don't like how this is written, so if you can always think of this as a fraction, so really all it is, if you think about it as being opposite, okay, instead of it being like 1 over A, I would probably write this more often than not. I would just write it as y equals b to the ax power, where I would flip these. So instead of, okay, because everything we do is, so I would stick with it like this, where it's y equals b to the ax power. Then if you think about it, everything we do with the x value is always opposite. Whenever we move it left and right, it's the opposite sign. Whenever it was a negative, we made it opposite this way. Okay, we moved it horizontally and moved it that way and did everything the opposite. So that's why I kind of leave everything like that, so then we don't have to get into, with the 1 over the a. Let's just go ahead and call it what it is, and just means that it's going to be the opposite. So if our a value is bigger than 1, then it's going to be a horizontal normally, okay? Here, if it was bigger than 1, it was a horizontal stretch. Whereas here, it's going to be a horizontal shrink. Okay? If it's between 0 and 1, okay, then it's going to be a horizontal stretch. Okay? So it's a stretch when we're dealing with, if a is bigger than 1, it's going to be backwards. It's going to be a stretch when a is between 0 and 1. It's going to be a shrink when a is greater than 1. So here it was a greater than 1. Here it was a 0 is between, or a is between 0 and 1. Okay? These are opposites of one another. Okay, just like we've talked about before. Everything, whenever we deal with the x, is always going to be opposite. So again, I'm not going to use the graph of 3 to the x power. I'm just going to use what they kind of give us, so you can kind of see how all of this is going to kind of fit in. Again, 4 things, right? We're looking for the y-intercept. We're looking for the asymptote. We're looking for the domain. And we're looking for the range. Okay? I would say more often than not, most students are just going to graph this and not try to move it left, right, up, down, things like that. So again, domain, negative infinity, positive infinity. Okay. Again, look for, there's no k. So your asymptote is just y equal to 0. So I'm going to have a imaginary line basically at 0. Okay. Then go with my y-intercept. So y-intercept, we're just going to take, we're going to go 3 to the 0 plus 1. So my y-intercept is going to be at 3 to the first power, which is just going to be at 3. So I'm going to put value of 3 right there. So again, we're in range. Okay, it's on the top side of my asymptote, so it's going to go from 0, from my k value. Okay, where did I get my 0? From right there to positive infinity. Okay, now it's completely up to you. Like, realistically, I'm probably just as well or just as easy to just take a few numbers. If I have, okay, my values for x, and this is just 3 to the x plus 1, okay, we already know what 0 is. Okay, you can go, so we know what 0 is. You can go 1, so that was just 3. 3 to the 1 plus 1 is just 3 to the second, so that's just 9. So, go over 1, there's 3, 6, 9. Okay, I'm going to run off the graph. That's okay. So go the other direction. Go negative 1. Go 3 to the negative 1 plus 1. Okay, then you can kind of see, well, that's 3 to the 0. So 3 to the 0 is just 1. So all we did was just basically take it. We have a few points. It's going to run along here and then take off. Now, I'm going to call this one good, or this one is going to 5. So we have 2x to 2 to the x power minus 3. Y-intercept, my asymptote, my domain. Okay, go ahead and negative infinity, positive infinity, and then my range. So again, now this one does have a k value. So we're going to take the whole thing. So my asymptote is going to be at y equals negative 3. So then negative 3. Now it just becomes, where's it at? Well, my y-intercept, all I'm going to do, y equals 2 to the 0 power minus 3. Remember, anything to the 0 power is just 1 minus 3. So y-intercept is at negative 2. So negative 2. Again, it is above my asymptote. So that means my range is going to go from the negative 3 to positive infinity. It's going to take kind of the same steps. So we can plug in values. Okay, 2 to the first power. 2 to the first power is 2. Okay, if I just go 2 to the first minus 3, 2 to the first minus 3 is just going to be a negative 1. Okay, if I go 2 squared minus 3, okay, that's just 4 minus 3, so that's going to be at a positive 1. Take it, and then go from there. Okay, the graph isn't a huge ordeal. Again, it's just one piece of the puzzle. Okay, you kind of plug and chug numbers. Again, we haven't used one graphing calculator one bit. Okay, and you don't have to. So understand that it's really pretty straightforward, pretty simple. Don't overcomplicate it, especially since we've already done this in Algebra 2 before. We'll talk about natural base E on Thursday and kind of go from there. I'll see you on Thursday. Your assignment's going to be in Canvas. It's just going to be a graphing worksheet. You can either print it off if you want, or you can just basically take what they have and use a graph paper that is on the wall.